Right. Hey, good day, all, and really appreciate the opportunity to meet with everyone today. And really a big shout out to the Litmus automation team for putting us all together and letting us share as a group. And hopefully I can share a little bit what we're doing here today. I want to talk a little bit about what we call operational technology transformation. A lot of people will say they'll talk about digital transformation, but I prefer to use the term OT transformation. And we'll talk a little bit why that is and explore that in a little bit more in depth. So what we're going to share today is a little bit about my company, where I work at Softserve, and then we'll give a definition. What do I mean by OT transformation? I'm going to try to keep it relatively simple to understand the context when I use the terms today. What do I mean by that? And then I'm going to share some latest insights. We've recently completed a survey over 400 manufacturers around the world, and we're going to share some interesting insights, what we learned, and what the globe is thinking about OT transformations, data collection, and the use of advanced analytics in manufacturing. Talk a little bit about some challenges, and then some successful case studies where people have done and made some good transformations in the OT space. And then we'll share some insights around what we believe and what we've seen to be a successful path of how to move forward on your operational technology journeys, transformation journeys. So a little bit about myself. I work at Softserve, and I'm the manufacturing industry success leader. My primary job is to listen to the needs of our clients and hear what their business challenges are, what the business outcomes they're seeking. And then I'll work with our teams to look at solutions that best will meet those needs, whether they're people, process, or technologies. So a little bit about Softserve. We are an engineering services company. We're not a product company, but we are able to bring some of the world's leading technical talent in a variety of different disciplines. And we also work in a different set of industry segments: manufacturing, oil and gas, retail, finance, life science, education, and energy management. We're extremely fortunate that we're able to support our clients in a variety of capacities, all the way from the light bulb phase, all the way through to operate. So we maintain capabilities for digital strategies and innovations. We're able to bring some very advanced technologies in the areas of AI, ML, robotics, big data, IoT, extended reality, and robotics, and even to quantum computing. We have a lot of team members involved in software engineering. And then to help support our clients, we also have capabilities and practices around product and enterprise platforms that we help bring into the market, and we'll add our services on top of it to help really bring it to life, tailor it, and customize it to meet the needs of those clients. And then lastly, our critical services. This is where we help clients make that jump into an industry 4.0 world, how we help take a factory into a cloud connected world. And that's done with our critical services. We're about 30 years old, 14,000 or so, 13,000 associates. And we're really proud of our net promoter score, which is pretty high. It's at 82. And we're very fortunate that we have a pretty good loyalty with our clients and retain about 98% of our clients that we engage with. That's a little bit about us. And let me talk about rationalizing OT transformations. And we're going to talk about what is the purpose? Why do we even go down this path? And if you listen to some of the sessions today, you heard a lot of team members and a lot of the talks for today. We're talking about finding that problem that's in the organization, finding the ways to actually show value of solving something that's big, something that can be has high value impact and is material to the organization. And I look at these 5 KPIs. When we look across a manufacturing organization, we focus on these 5 key areas. We focus on operational resiliency. I'll talk a little bit more about that later when we talk about a design pattern. But when you move and you start to add capabilities like the cloud connected to our OT world, where in many instances they were never connected, we must design and build and anticipate resiliency to use the power of the cloud to help improve things such as uptime and performance of the equipment in the factory. We look at factors centered around sustainability. We can leverage the OT transformations to look at ways to improve energy management and to improve sustainability. And sustainability and energy management are two very discrete items. We talk about production optimization, the ability to increase, in the ideal world, increase throughput in an ideal situation, as I was saying, for a lower cost. We look at means to improve product quality. And another one that many times it does get overlooked, but we have a big focus on it as a company, it's employee safety. By bringing in new types of technologies that can be inspired by OT transformations, we can actually improve the safety within the employees in the factory environment. What's imperative about this at the end of the day really is when we define a journey, we're talking about this transformation, we've got to make sure we bring it back to some of these key KPIs, and we need this to help improve that return on the investment. And all of this, and you'll hear me talk about this a little later also, we talk about this to really avoid that trap and that pitfall of getting stuck in that proverbial science project. So you heard me talk several times about OT transformation, and it's a derivative of a digital transformation, but what does it really mean? From our perspective, when we work with our clients, we try to keep it as simple as possible so we can connect and understand and help drive why we're making these changes. But at the end of the day, OT transformation is about moving from a world of isolation into a world of integration. So if you look on the left side today, still about 2/3 of the world's manufacturing plants are really not connected to the cloud. And if you think about how they're running today, that we will measure machines and people and the process in isolation. And then what I see a lot, even though we have all these different machines and different data being inputted literally on paper, we'll see it get aggregated together within a spreadsheet. But what we're trying to transform into, going from that isolation to the integration, it's really able to leverage the cloud to scale, to aggregate your data, store measures, and then in a very particular instance, then integrate yourself into a world of digital twins that allow me to see the performance across my entire factory footprint, where I can see what happened in the past, I can see what's happening today, and then when we can optimize, we can start predicting what will happen into the future. So when we talk about OT transformation, that's really what we're talking about. We're talking about taking factories that historically or from a legacy practice were isolated into a world that's fully integrated. And if you think about it, really what we're trying to do, some would say, well, this is really contextualizing the data that we're ultimately going to use. We're bringing in all the different facets, all the elements from that machines and people on the floor, aggregating it together into a unified cloud structure to allow me to see what's happening on a global footprint. Now, this is a more detailed diagram of that. So we get to that future state world. What does that start to look like? Some of the things that we do with our clients is we help them define a design pattern that becomes a blueprint of where they want to ultimately take their underlying infrastructure to connect and to leverage these new types of capabilities that Industry 4.0 brings into a manufacturing environment. So a little bit about this. So we think about a standard ISA 95 manufacturing stack. In the manufacturing world, we have a tendency to hold on to things for a very, very long time. And that's why we have a lot of legacy equipment. And sometimes our manufacturing stacks are the same way. So we don't really advocate ripping and replacing. We want to be able to build upon the infrastructure where it makes sense to extract information. So we need to understand the data, what I call the goes intas and the goes outas within your manufacturing stack. We talk about defining a very solidified data model for each one of the factories. And there's two really powerful components about data when you hear us speak about it. When we talk about the data on the edge, I call this OT real-time data. And then when we we move up into the cloud, that data becomes IT lagging data. So it's really important to understand when we're designing and building these OT transformations, if we're leveraging the cloud, we need to think about what data will stay at the edge, what data will go up into the cloud. And there's a lot of studies have shown that each week, if you aggregated all the data that a factory generates, some reports have shown it's up to 5 petabytes. When you think about that, that's not really practical to continually bring that much data up into the cloud. So we have to build a smart data lifecycle. What do I keep at the edge? What do I bring upstairs? And then we start looking at how we connect it, how we help define an edge computing strategy. This is unbelievably important in your OT transformation journey, that it must be resilient against inevitable network failures or even cloud failures. Sometimes things go wrong. And so when we think about that operational resiliency, we got to guard against, through good risk management practices, that our edge computing infrastructure must have enough intelligence to keep running in the event the cloud side has a challenge or the network has a challenge. But when we get it to work in harmony, we get them to work in concert together, we start to bring in the advanced capabilities that the cloud can help us scale to. Such things as digital twins, operational analytics, where we really look across all the different functional segments within the factory, fault-tolerant hyper-automation, that by using the capabilities of robotics, computer vision inspection, when you combine that with AI ML, there's certain things and tasks that we'll do in the cloud, tasks that we'll do on the edge. And we have to optimize for that. For instance, a lot of what we will do, the training of the models in an AI-centric world, the machine learning models, that will take place in the cloud with very large data sets. And through ML ops, we'll move that model down to an edge device where it can be used in an operational environment. So in essence, what we do, we get a symbiotic relationship between the OT world and our IT world up in the cloud. So let me share a little bit about this research I was talking about a few minutes ago. I mean, I'm only going to just highlight a few different items on here, but as I was saying earlier, we interviewed about 400 manufacturers from around the world, and the purpose of this was really to gain insights, how people are collecting their data, using manufacturing analytics with a special focus on operational equipment effectiveness and digital twins. Let me share some insights that we learned. On a global priority, when people think about their OT transformations, the number one item that we found that they were reporting that the world's plants, manufacturing plants, over half of them, their number one priority is upgrading their physical infrastructure so they can connect it. But we were actually shocked when we learned what ranked at the bottom. So he was improving the OT security. So there's an opportunity as we do these OT transformations. Many times we're now going to connect factories that were never networked into the cloud, but we have to bring the OT security right along with it. So there's a big opportunity for us to work with our manufacturing clients to make sure that when we do connect to the cloud, we're connecting it in a safe way. A couple items we also learned. We asked several questions around automating the data collection. That's a component of the OT transformation. And what we found, when people had a strong automated program for such things as operational equipment effectiveness, we found that they were actually using the data more effectively to make decisions. And so stated a little bit different, one of the challenges that we've seen with clients is they will spend 80% of the time collecting the data, 20% analyzing. And when we can do an OT transformation, we reverse those. Our goal is to get it where it's 20% of the time is data collection. And we're spending 80% of our time on the analysis and driving action. So we want to have a closed loop system. So what we find is when we have a strong OE program where data has been automated, it has a direct impact on productivity and product quality. So there is a material change in the business when we actually do these OT transformations, bring the data together, apply more sophisticated analytics to help drive faster insights into the business. So what are some of the challenges that we see? And we break down the challenges in three areas: the people, process, and the technology. Now, as technologists, sometimes we have a tendency to get focused on the far right side. But what we have learned over the years that we could deliver the best technological solution. But if we don't have the support of the operators, the people who are using it, this program will fall flat. And we believe this is always a contributing factor to the proverbial science projects. We get enamored with the technologies, and we did not address the people side. So when we think about the challenges that we have, we still have an IT OT convergence challenge that we're bringing the cloud and the OT world together. And we actually have cultural differences. We have these cultural differences where IT departments were designed to be very efficient. Whereas an OT world, a factory, has been designed to be very effective. And those two have clashed. So to prevent that clash, you can see we need to bring those two operators and those two cultures together. On the process side, that we have to think about how are we going to actually institute the changes in the workflow when I introduce an OT transformation. We've got to think how the humans that we're working through change management, how we're going to bring the tools of process that they're using, how are they to interact now? What changed? And they went from a manual world to an automated world. How does this work together now? And then lastly is the technology. Once I understand the people needs, we understand what we're going to change within our process side, then we can look at the technology. And if there's an old saying that if you've ever been in one factory, you have been in one factory. Every factory is different. And even within the same company, they're going to be different. Why does that happen? It's because they're designed to be effective, not necessarily efficient. When we do OT transformations with the technologies, that is starting to bring an efficiency component that we've learned in the IT world. Now we're going to try to bring that into our OT world. But it brings all different types of challenges. We talked earlier that a lot of our legacy technology in manufacturing, there's that saying of it's not broke, don't fix it. We will keep using, especially if it's expensive capital equipment, we will keep using that if it gets the job done. So that creates unique challenges where we have to overlay on top of the equipment of how we can get data. For instance, I had a client that had a press that's been in use since 1955, but we needed to get the data out. And so we came up with creative ways to use computer vision. When with computer vision, we could gain a lot of insights and take an analog system, actually convert it to digital data. So we have to be creative and overcome a lot of technology challenges that are from the legacy side that have been used in many times since the 1950s. So we see broad challenges on the people, the process, and the technology domain. Let's talk about some people and some organizations and use cases where they weren't able to overcome those challenges. So the first one I want to share is the factory utilization. This client had 16 different factories, and they had that same example of all the factories were running in isolation. And the challenge for the executive teams and the people running the operation, they really wanted to get a better real-time insight across their global footprint of their factories. So by working with them, coming in and developing a strategy for an OT transformation, we were able to make very strategic and very unique updates for them within the factory environment and bring the data into the cloud and create insights for them across their entire manufacturing footprint. And so it really helped them to gain a much faster view of the challenges that were happening. It's not necessarily real time, but it gets much, much better. What they were dealing with before was a world where the data at the end of the month was being, or at the end of the week or end of the month, the data was all being populated in spreadsheets. It would all come together. And then some person would have to aggregate all this data. And at most, they were getting about a 4-week lag of information. Now, today, across their 16 plants, they can see, and within 24 hours, all the data that's happening within their factories and be able to make decisions much, much faster now because of this connectivity. Another client had a challenge with the ability, they wanted to improve the product quality, detecting issues. And they had a very precise printing business, a type of printing business, where they wanted to make sure that the errors they were able to first detect, but more importantly was prevent. So it's not good enough just to build a solution to improve better detection. This is why that third challenge I was mentioning earlier about process. So even though we gave them an ability to better detect errors, if we only just piled up the errors, we didn't really fix a problem. We actually created a problem. So now we had to model the larger number of defects coming in. What was the process changes we needed to do? But more importantly, to determine and put a stronger program in to prevent the issues. That's why you just can't look at the one-point solution. We had to actually look through changes in operator behavior, update the processes with the technology, and make it closed loop. This one's a little bit outside of the factory, but it still shows, I still wanted to show the way of using how we can upgrade a fleet of trucks to bring data in aggregated across a wide footprint. In this particular example, we had a challenge with a client who had a high value cargo. And when they were stopping along the way, the drivers moving the freight, they couldn't tell that the driver actually stopping in a safe place. Was the driver in danger? Was there something wrong with the vehicle? So we helped them redesign the ability to monitor and guide and make recommendations where the truck should stop. And now, because we knew where we were instructing and giving insights where they should stop, if there was a deviation, this could be an alert off of that to actually help give assistance to a driver if it was needed. So a lot of different types of capabilities were brought in and advantages by overlaying a telemetry system for a fleet of trucks to give them insights on where the status of the truck, where they were stopping, and optimizing the routes for them. So those are just 3 examples where it has been successfully applied. But what's the path? How do we actually move forward in this type of model? And what's our recommendation for this? So I'm going to give you some insights and some of our learnings in working with clients. I originally was going to title this presentation, and I had a little bit different, was called Manufacturing Darwinism. I still think it's very, very appropriate because really what we're looking at is survival of the fittest. And by introducing these types of capabilities with an OT transformation program, it helps position the company significantly better in a competitive situation. But it's a journey, it's an evolution, not a revolution. We don't want to boil the ocean. We want to be very realistic. But we have to also help guide our clients to understand there's some behavioral changes. Get ready that in a manufacturing world, we have a tendency to focus on capital expenditures. But when I start to do an OT transformation, I start to bring in these big cloud components, and I start bringing in the data lakes at a larger scale, that changes from a CapEx world to an OpEx world. So we got to make sure we're aligned to that. And then we also want to think about the people side. We know we have challenges in an IT, OT world. So one of the things we want to focus on is make sure that our OT and IT teams are aligned from an incentive standpoint. Then we start setting the stage. We set that stage, and always our recommendation is we always must bring the operators in and the IT OT team members. They must be part of the process. If you do not bring them in early on, the odds of success of your OT transformation program will drop dramatically. And we also want to know what success is. Before we jump into a proof of concept or a pilot or rolling something out, we want to know how to measure success. That's why in the beginning of the presentation, I was outlining those business drivers up front. Understand why we are doing this and what's driving these changes that we want to introduce. So as we roll them out, we can actually measure against that. We want to make sure we have a baseline established up front. We'll do that deployment, and then we measure, were we successful? Did we get the change? And then lastly, in the stage setting, make sure we have executive sponsorship. It is inevitable ties will happen. Now, as we get ready for the broader path that we're going to follow, there's some steps, also additional steps we want to be able to do. We want to think about the vision, that cross-functional team. We really want to have that list of problems that we want to attack. And more importantly, because we don't want to boil the ocean, we want to have a prioritized list of that. I've heard in several talks today that we were talking about data models. We are huge on data models. And that design pattern I was showing earlier, we were talking about the life cycle, the data life cycle within the factory. And as it moves from the edge up to the cloud and back, we've got to make sure we have a well-defined information model for that. And then lastly, we don't worry that if it fails the first time. Failing is really just another word for learning. And so we're going to be able to move forward with learning on this. And then lastly, what I want to share is here's a strategy that we follow to move forward. We look across the board, and this is the path that we talk about preparation. That we work with our teams to understand what are the objectives we're going to that we're going to attack. Then we must assess what's our readiness. And then if we have that readiness, and it's very important that we understand right up front, what's our business case in that budget? What are we willing to do? And once we have a really good roadmap defined from that, then we can start putting in different work streams and start putting them to validate what we're thinking. We start implementing those work streams, and very, very important, we must think about support and maintenance. For too many times that we will put the technology, but we didn't think about, well, how are we going to support it when something goes wrong? And that is absolutely inevitable. Things do go wrong. We don't want to be afraid of it, but we want to make sure we have a support system to help model that. And then lastly, even though there's critical challenges and items that can hinder the effort, hopefully what we're able to show today that these new capabilities that we can bring have tremendous upside. Our data from our surveys show when properly deployed, it can have a very material impact on production optimization. But I can't reiterate this enough. We must take all three pillars of the people, the process, and the technologies. And we take them in that order: people, process, and technologies. So with that, I'm going ahead and stop. I really appreciate and want to give a big, once again, another shout out to Litmus for sharing, let me come to share with you some of our insights and our experiences, and hopefully you're able to connect to just a little bit of this as we move forward.